And this workshop has two pieces. First, we're going to have Greg Labbé, a blue-green group, not the green-blue group, or the blue group.
No, it's
They're
not
a group. Oh, it's not a group?
It's not a group.
It's not a group?
It's not a group, it's a group.
Okay, it's the blue-green group. And we have Marco Icampo from the City of Toronto, who's going to be here talking to us about the HELP program, which is a new city program that will allow homeowners to borrow money on their property taxes to do energy retrofits. So I am going to turn it over to Greg. Thank you for coming in, Greg, and I'll let you tell a little bit more about your company and what you do, and why you're the one who gets to do this session today.
Thanks, Paul. Great, thanks for coming, everyone. I live in the West End, and you know, double brick houses is something that has been on my mind for a very long time. I used to work with Greensaver, doing energy retrofits of existing houses in the GTA, and I managed the retrofit crews for 13 years. And so yeah, I've seen a lot of different things, and now my business partner and I have broken off and we formed our own consulting firm where we work with builders, architects, and homeowners to make their houses more energy efficient. Blue Green Group, we're a Toronto-based consulting firm where we're exclusively focused on high-performance homes and deep energy retrofits of existing homes. Yes?
I forgot to mention, there's a couple photographers here. We do some stuff, post pictures on our own website, and then we also provide content and information for Snap, which is the local newspaper. If there's anyone who really is opposed to having their photos show up anywhere, can you just raise your hand so we know? And then we will make sure that we don't put you in any of our photographs. Sorry about that.
No,
carry on, Greg.
Oh, good. Actually, I want to put my hand up for that one.
Yeah. You already signed the waiver.
Okay, so basically we work in the planning phase to try and optimize the design with the architect and or homeowner, the builder. We also, during the construction phase, will actually go out and test houses. We do a lot of diagnostics on houses with, they could be $1 million doctor's offices with persistent drips in the ceiling to just condensation ice damming. We do a lot of diagnostics using infrared and blower door together. And we also work on the commissioning side. Our houses are getting more airtight, whether we like it or not. And by necessity, we need to have a ventilation strategy for our houses. And quite often, we come across ventilation systems that are not delivering optimally throughout the house. We're talking about the lungs of the house here. And really, I think for a small fee, you can balance out a system to make sure you're pulling and pushing the same amount of air in and out, but also making sure that certain rooms get the requisite or the intended design volume of air. All of these things can be done. So we work with builders, basically it's two guys, Sherman Akavi and myself, and he's an engineer from, he studied in Germany, the passive house sort of standard, that was his master's thesis. We kind of see ourselves as cross-pollinated between architects, builders, and homeowners, and we get to see a lot of different builds, and so it gives us the strength of knowing what kind of building materials work, where do we find typical leaks and that kind of thing. So that's our whole model. Basically, you've got 100-year-old leaking houses consuming a lot of energy. The average new house is a lot less energy. Then you get an Energy Star in R2000 where there's a little bit more testing and some planning involved. And then you get into sort of, what I'll call the passive house or near passive house. It doesn't have to be a passive house certified house. We're aiming for, the good enough house, the But rigorous planning and testing is required. And, we basically, our whole thing is, would you pay 5 cents to try on a $100 pair of shoes before you buy them? We think, for sure. That's enough of the advertising campaign, sorry guys. The agenda today. So if any of you guys have questions, I'm in the neighborhood, and I'd be more than happy to answer questions. There are business cards, brochures, and I brought a sampling of different materials. Thank you. Sarah Doucette, that's awesome. You're doing such a great job. And I brought some of my own personal library books. If you don't be checking them out, because I love them. I cry when they go missing. Not that they go missing very often. So the agenda today is where do we start, how to prioritize upgrades, what's the potential, innies versus outies, is my home a double brick house? Confirming that some houses are not double brick. Site assessment, what to look for. We're going to do a bit of building science. Common issues and retrofits, wall insulation options, etc. So that's what we're going to cover today. It's always tough trying to gauge how technical to get, what's going to be the narrative for a talk. And I generally assume that most people who come out want to bite into something a little bit more juicy, and I'm hoping that I can do that here today. And if any of you guys have questions thereafter, give me a call. I'll back it up if I can. And it'd be sort of my pleasure to sort of give you a little bit more background information if needed. But it's pretty ambitious. I'm starting a little bit late, and Marco wants to talk, and I don't want to put Marco to sleep. He's here to talk about a very important program with the City of Toronto that's piloting a very exciting program here. So, consider to be an energy retrofit. Are any of you considering it? Is there hands up? How many of you guys are considering? Okay, so we're looking at like 50% of the people here. That's fantastic. So, the first thing that you do is you learn about your house. Educate yourself. So that's the cardinal rule. The first place you start. There's a lot of great places on the web. Apparently, the presentation here is going to be posted online, and there are links at the end of places where you can go to get more information, etc. So, for financing, Marco's going to talk about that in a little bit. The HELP program, the Home Energy Loans Program. There are options there for low income. Check out the Home Assistance Program at Toronto Hydro. There are some programs that do offer some retrofits and upgrades for people who don't have a lot of money. So, did anyone go to Goderich after? No. So, I think that the debate is over on climate change. I think that we all know that it's upon us. And, I think that we have the responsibility to try and do something right once, So putting in the emphasis on planning is very important in builds. Shervin reminds me of one of the professors, and he says in Germany, it's not like in Canada, where in Canada, everyone says, oh, professor. No, in Germany, the title professor is bestowed on very special people. He said he had one professor who said, every construction is a violence against nature. And it's, as much as I love seeing houses get built and testing houses, it makes me, it begs the question, how much planning should we put into it? And I dare say quite a bit. So these are houses, or this is a church and houses in Goderich. I happened to be there just after the tornado. And, this is 1878. This is over a century. So we designed for the 100-year storm, or the 50-year storm. Is the 50-year storm going to happen every 20 years? I don't know. But the science seems to suggest it will. So when we build our buildings, we design for a little bit more wind. We design for really superb passive drainage. Getting water and wind are going to be our enemies. I'm assuming that the earth is not going to tilt. We're not going to get more solar. And the next is things to think about are embodied energy. We'll talk a little bit about steel is especially, so does everyone here understand the concept of embodied energy?
No.
No. Embodied energy is the amount of heat, beat, and treat. When I'm making this water bottle, I have to take polymers, heat them up, compress them, and inject them into a mold. And that's the amount of energy that goes into making this water bottle. The same thing goes with building materials. So for instance, we see straw bale, aggregate, soil, cement, stone. So these are all low embodied energy. So the megajoules of energy per kilogram of weight or per meter cube of volume is lower in these materials here. So lumber is fairly low, 2.5. Because we have to saw it in half, etc. Now, if we're going to build a house out of concrete, this is a little bit misleading because of I'm trying to think. I'm trying to look at this here. Why is concrete megajoules per kilogram? So per kilogram, it doesn't weigh as much as wood. Lumber, 13, okay, so concrete block, you can see here that it's twice the amount of energy goes into making per meter cube of concrete than it is for wood. So generally speaking, we try to aim for materials that have a lower embodied energy. And when we get into steel, we get into really high embodied energy per meter cube. It's hard to sort of gauge it on a volume versus weight basis. But generally speaking, we're trying to choose materials that have less embodied energy, and when it comes to insulation, especially, the insulations, polystyrene versus cellulose insulation. You can see the cellulose insulation here. If we're comparing two different types of insulation, it's orders of magnitude less when we're talking about cellulose. So choosing your building materials based on the amount of energy that goes into making as well, something to consider. So notes on the building code. The Ontario Building Code applies to new buildings that are being constructed. When you apply for a new construction permit, it applies to the new part only. When you are renovating an existing house and you're forced to get a building permit, there's nothing in the building code that compels you to increase the performance of a house. So if you're gutting your house and you're expecting that your builder is going to take care of things, don't assume that. Because the code is not retroactive. Okay? So there are often walls that get uninsulated, especially staircases. You'll see, staircase, well, we're just going to leave the staircase there. We're not going to insulate around there. So you end up having lots of sections of houses that are not insulated. So just be mindful of that. There's also, if you're putting an addition on a house, the requirements are different for a new construction versus a renovation. And if you're putting just an addition or a second floor addition or back addition, you may not be compelled to do a ventilation design, which if you've got a lovely Rumford fireplace like this, can fly in the face of how it's going to operate after the house is finished. We're doing some testing on houses where, the ventilation design, which is normally part of a new building code, is not done in these houses. So sorry, I'm jumping around a little bit right now. We'll sort of streamline things a little bit more as we get on. And remember that inspectors are there to ensure the minimum building standards. They're not there to test the performance of the house. If you want performance, you have to spec it in the contract. And that's the big thing here, is the contract is your only device for requiring more than better than code. So that's my advice to you. If you want better than code, then you've got to spec it in the contract. So on Maslow's sort of hierarchy of energy efficiency retrofits, so this company here, MN Powercom, has put together this lovely graph here, which says that the first rung is understanding. Can everyone see this? Should we turn off a light? Is it fine for me? How about yourself? For you? Is it good? Okay. So, is that good? So, the next one is low to no cost. So, energy choices, TVs, computers, just, basically these are the social habits, changing social habits. Close the front door, those kinds of things. So those are changing things that we can do. The next is lighting upgrades, so changing lights in our houses. The next is air sealing, and then we get into appliances. So as we move up the scale, the complexity is increased and the investment is increased to the point where we have solar electric at the top. Now, things have evolved since this was printed up because the price of solar PV has plummeted, relatively speaking. And we're also getting some good rebates from the utility, or not rebates, but the utility will buy the power from you. It's to the point right now where experts like Martin Holliday from Green Building Advisor are saying, forget installing this amount of insulation under your slab. Install this amount of insulation under your slab, your concrete slab. Take the rest of that insulation and put it in PV panels on your roof. Okay? So there's a lot of interesting things that are happening right now. And it's something to bear in mind when you're going about. So the next thing is I spoke to an architect a few weeks ago here in Toronto, and her daughter, they renovated her house, and her daughter has learning disabilities, which with the onset of her renovation, they were living through renovation. So it's a bit of a cautionary tale that lead is to be avoided. We don't want to breathe it in, we don't want to eat it especially, okay? So if you're renovating a house, in Canada there's no laws about lead paint and renovations, whereas in the States, they're really clamping down on contractors. They've got to be very clean when they gut houses, when they drill through lead paint. They've got to test before and after. In Canada, there's no such thing. So just be mindful of this. If you're living through renovation, just know that you should really manage the dust in the house well. And of course, you guys all see, you've all seen this. Can anyone tell me what that is? I wasn't going to say it, but I'm glad you guys said it. So sorry? So just protect yourself, protect your community. Last summer I saw a guy ripping off the gable, and the cedar shingles on the gable end wall. He's pulling it off, no mask, and underneath that was a sheet of asbestos. And I'm like, oh, geez, all of that's falling. What do you do? Are you morally compelled to say, look, stop? You're killing yourself. You're imperiling the neighbors. There's a lot of whoever's downwind from that. What do you do? But every house, I guarantee you, has a piece of asbestos buried in it somewhere. Innie versus outies, so they're both winners. So outies, we're going to talk about outies. Outies is when you insulate from the outside of the building. Okay, you change the curb appeal of a house from the outside. And innie is when you gut the inside of the house and you insulate from the inside. Some people do a combination. They'll put an addition where they'll make the addition, it'll be a stucco that won't match. It's an addition. And whereas the inside, please come on in. There's some coffee and some cookies there. So the outie, basically, you might be losing the character or curb appeal. There's the perception that brick is quality, but there's really few risks to durability of insulating from the outside. There's really no downside, except that you'll see in a minute where the downside is. Innies, however, there are risks to brick's durability for wet and cold climates. And there's the perception that interior floor space is reduced, which is rubbish. This is what we'll talk about today. We're going to focus on the innie because the outie is really, it's an easy thing to do. I mean, you clad your house with styrofoam and you could live in your house and sip coffee, look at the workers outside as they're freezing or whatever. So here's an example of why outies are really tough. And, we all live in the area. You've got these, you can barely bring the garbage between the two houses to the front curb, let alone insulate it. So there are fire requirements, there are issues there. Personally, when I look at this, I kind of think we should be making a thermal bridge between the two houses where they're just, connected and air sealed together, as opposed to having that wind tunnel. And just leave it at that. But of course, it's that detached versus attached sort of stigma. I'm not going to go there.
Don't go there.
Yes. So I'll ask you guys. What do you guys feel about this? Here's, I'm just gonna say it, this is done on the inside, this is done on the outside, Audi, I'm lying, I don't know if this is done on the outside, not on the inside, but let's just say that it is. So this one's done on the outside, this one's done on the inside. What do you feel? Does anyone feel a strong objection to seeing a stucco? What about something like this, where they just bulldoze the old house, you know? This is down the street, right? These are all houses right within a kilometer radius of this library here, okay? I think it's a beautiful house, but it doesn't fit with the character of the street by no stretch. What about this?
I think the issue is if all the houses started to look like that.
Yes.
That's when people would start being concerned. If every house was stucco, then it's like, not.
Yeah, you lose the character, but I don't know. I don't know what's right and what's wrong.
Yeah.
And all I'm saying is that, I have my own personal bias, but
Yeah.
who am I to say, it's a lot cheaper to do it from the outside, you can,
For sure.
for 50 grand, you can, 50 to 100 grand, you might be able to clad the entire house,
Yeah.
and there's not a speck of dust, you don't have to do any work on the inside, and you're pretty much done. Now, I don't want to say done, but most outside cladding are done, the detailing is not there for high performance. And, to me, I think that they could be done a lot better, so, but, these are examples of houses. So let's look at what's possible. Here's a house in East York. I know it's not the Junction. It's a 1950s house, so it's a block and brick house. And I did a blog on this because after I had some real eureka moments with regards to foam sprayed on brick in these houses. And we posted at Green Building Advisor, we wrote a little blog for them. And that's a possibility. Like I said, I am not sure what's happening here. That is very strange. Okay. Sorry, guys. There's my pie. I don't know why it's doing that. There we go. There's two halves of the same pie. And let's just say that that's doors. There's your window pie. It's a very small pie. So sorry about that. I don't know. I must have inadvertently cut and pasted. I could fix it, but I won't do it. The breakdown is basically there's a lot of air leakage and there's a lot of heat loss through the main walls as well. So here's an example. You can see the brick on the inside, the roof here. This is what it looked like before. Here's the wire. There's the same wire coated in foam, and we've got like a nice purple foam in there. And the contractor actually cut the wood floor, the planking, the subfloor, cut it so that you can get continuous foam behind it. Oh my gosh, what is going on? All of my graphs here are not showing up properly.
Compatibility with York?
No. Sorry guys, hang on, let me just have a look here. There we go. Okay, what's with that? It doesn't like it? Okay, well, let's just see here. Sorry, here, let's,
You need to retrofit your windows.
what does it mean? All right, so the graphs, I'll just pull it back like this for the graphs here. Let's go back here. There's your pie, okay? So you can see the lion's share of it here is on the main walls, although it's only a 1.5-story house with a fairly large attic. There's a lot of heat loss through the uninsulated walls. Okay, the next is air leakage. Big energy losses in air leakage. And then windows. Okay? So we've seen this slide, we're looking at this now. Now here is what the energy model showed for the energy loss in the house. So basically, here's the energy loss through different skin surface areas. So the air leakage is almost, when we measured it at the start, was almost as much as the heat loss through the main walls, which is pretty stunning. And in most of our houses in these areas, these 2.5-story houses, we actually lose most of our heat through air leakage. Most people are like, it's the windows. It's not the windows. Sure, there's a little bit of air leakage with windows, but you can change your windows. You're not going to see, you're not going to see a huge, it's not going to be from there to there. So basically, the energy model helps us really put things in priority and really sort of say, okay, we're not gonna spend $20,000 on doors, okay? Because there's only X amount of energy, leaking out the doors. So let's not obsess about the doors. Let's obsess about the main walls, the air leakage, the basement walls, and the ceiling. So this gives you the priority, sort of, yes?
Could you just, when you say air leakage and ventilation, I actually don't know what that means.
Okay. This is such a good point, and it is, allow me to tease it out. So air leakage is what happens when your house loses a cubic meter of warm air and it goes out. So during the wintertime, we'll see a graph a little bit later that shows us what stack effect is. We're constantly losing volumes of air, heated volume of our house to the outside. Well, wait a minute, did I say we're constantly losing air to the outside? Do we have a vacuum in our house? How can we possibly constantly lose? What, is there air that comes in to replace it? Yes, okay. So now we know that the air that goes out is replaced with incoming cold air from the outside. So we have this cycle in our house. It's called stack effect, okay? So that rinses out cold air. So this is air leakage. Now ventilation, and this is, Paul, I'm so glad that you said that. I should probably devote a slide to just sort of dividing the two. I try in here to be very careful about, to separate those two topics. Ventilation is the air that we breathe. Now, I have to be careful because there's also ventilation for the attic. People are like, put some mushroom caps on the roof. We need some ventilation in that attic. So that's not the kind, we don't care about that ventilation. That is not inside the house. Ventilation is what we humans need to keep us healthy. So we need low CO2 volumes and high O2 volumes. We need high oxygen volumes, okay? So we ventilate our house. We try to move the air, export it, and import new air. Some of them are just export only, some of them are import-export. And generally we like to have the balance where there's the balance of import, export, and it uses an HRV.
Okay.
Is it?
How is it leaking out if it's not going through those other, like through the walls or the windows or the doors or the basement? Where is it leaking to and how is it leaking?
Okay, so when I go out and I test a house for air leakage, I put my big fan on the door, and I measure the whole air leakage in the house. Some of the air leakage could come from those windows, okay? Some of it can come from this fireplace, some of it could come from the lights in the ceiling. We don't really know, but what we do as building scientists, we say, we're just gonna glom it all together in one bar graph here. And unfortunately, we also include the ventilation exhaust. So if I have a balanced ventilation where I am importing and exporting with an HRV, that heat loss goes down a little bit, okay? But if it's exhaust only, if I've got a little bath exhaust fan and a kitchen range exhaust fan, then yeah, it gets a little bit higher. But to answer your question, you're absolutely right. A portion of this would be put on the basement wall, another portion would be the front door, it's always leaky. Another piece would be for the windows, okay? So we can divvy up this and apportion it throughout all of these different parts of the skin surface area. And unfortunately, unless we're gonna test them all separately, we're not gonna do that. So generally speaking, we'll just break it out in a column by itself. Did I answer your question or not really?
Did, but then I don't understand how we measure the width, like all the different separate.
Okay, so when I do a computer analysis on a house, I measure the skin surface area of the house. It's like if I take off, all of my clothes and I lay it down on the floor here. Sorry. I will keep my undergarments on, but it's just my undergarments. I'm just interested in the skin surface area. And it's an accounting process where I say, okay, the guy's got 1 square cubic, or 1 square yard of wool pants. That's R2. He's got a cotton shirt, 2 square meters cotton shirt. That's R1. And so you do an accounting, and you break it down by skin surface area type, and that's how we do it. Does that answer a little bit more? Or not really?
So optimally, you should have balanced leakage and ventilation. Is that right?
There will always be air leakage. The house will always
Well, you
have...
want some, because otherwise you get too much stale air and right? You need
Uh,
some fresh air.
This is where we separate the church and state. Okay, there's ventilation on one side, which is for our health, and then there's air leakage. And you're absolutely right that historically they were conflated. By virtue of our houses leaking 17 air changes per hour, so the whole volume of the house changing over every hour on Christmas Day, meant that we got a lot of fresh air, but it was usually not balanced throughout the house. The basement got a lot, the top floor didn't get as much, so, or, certain rooms didn't get as much, so you're right. And now, as time goes on, we're taking apart the air leakage and we're separating it into two components. We're making houses more airtight. And so we know that because they're more airtight, we've got to look after ventilation. We've got to really focus with a bigger magnifying glass. More attention needs to be paid to ventilation and not attic ventilation. Nobody cares about attic ventilation. That's very passe when it comes to building science. Okay, let's see here. Okay, spent a little bit too much time on that. Sorry. Okay, so here's a passive house retrofit in New York. What is different on this slideshow? Can anyone tell me what's different?
Yeah, blue cars.
Blue cars, yeah. So those cars are efficient cars. There's no heat loss in those cars. But you're right. Cars are cold. It's actually pretty funny because when you go outside, you can see, that this car here was probably running a little bit. The motor's still hot here. There's no heat in that blue wall. Anyways, I digress. The point is that there's one house here that is not losing a lot of heat, and these are, more than century plus homes. So here's, the house in question. This is what it looks like from the inside and the outside. And this is a blend. We talked about Inis, Audis. This is kind of a blend. And I think it's very tasteful. Personally, it's a bit of a modern twist on is this offensive? Should I change the slide? No? The evolution of laying brick. So the evolution of laying brick started off where the structure, the brick, the double brick that we have is actually structural. So the load is borne on the brick. The floors that we stand on are borne on the brick. The roof, all of that load is weighted down on the brick. We changed it a little bit in the 1930s. We said, 2 courses of it is just too much. It's easier to lay bigger blocks that are the same width. And so this is what they call block and brick. So in Etobicoke, all of those story and a halves and bungalows that you see, they're mostly all like a cinder block on the inside and a decorative brick on the inside. And then we move to today, 1960s to present, where we have a brick veneer and a wood frame wall. And in this case, the wood frame wall is what holds the floors up. It's what holds the roof up. Okay? So that wood frame is really the structural component, and we just sort of wrap the house. Once the whole house is built, we wrap the house out with brick that is our cladding.
But they were using that method back in the 1800s too. My house was 1881 and it's a wood frame with a brick veneer.
It is, sort of. And I would say that you're kind of right. Yours is like this, in that there's no drainage, there's no intended drainage layer. So, I don't want to, you're absolutely right. There are hybrid houses, and I'll show you some hybrid houses, sort of the Victorian, sort of the more pointed roofs, not the Edwardian kind of style. I'm not, there again, you should have an architect here. I shouldn't speak Edwardian, Victorian, I'm still a little bit messed up on that stuff. But basically, in a new house, what you have, so I'll just go through the presentation. I'll sort of tackle that a little bit later on. The old double brick walls were load bearing. Now in North America, as I say, the house is completely built out of wood or steel, and then they clad the outside. It's just like putting siding or stucco. Okay? It's more of a decorative and keeping the elements out. And so this Kensington market, and for all of you who are saying, today's brick is so much better than the old way, and there's problems with both. So this is Kensington Market. This is a building that was built less than 20 years ago, and I just love the fact that it says historic restoration. Not even a 20-year-old building. Look, all the lintels are failing here. It's like, guys, come on, get your detailing right. So it's not just the old houses that are suffering, new houses as well. So basically, this is what a new house looks like. So this is a construction site in Brampton. So they've got here, this is what your house is missing, okay? Your house is missing a rain barrier here. So in other words, anything, so the sun, if it rains on that wall and the wind pushes the rain into the wall and the rain gets back here, it will come down and get kicked out here, okay? You'll see little weep holes. You probably don't have weep holes. You could probably retrofit something, but you probably don't. So that's one thing that your house doesn't have. The other thing that your house doesn't have is a complete airtight layer. You can see the Tyvek coming in here. There should be foundation wrap around here. You can see the air barrier here. So that basically there's a continuous air barrier in the house, and that's what's missing in all of our houses is a way to shed the water, we kick it back out, and a way for the air to stop in a very defined way. Since vintage brick has no barriers for draining driven rain, has no continuous air barrier system. Vintage brick has lasted so long because it drove out moisture with heat, and was the success of all of our houses. It was thanks to the fact that there was no insulation. We dried out the houses very nicely. Okay. It's stirring up controversy. The concern is that elevated moisture in the old brick can't dry when cold, and it can degrade over time. And Joe Seabrook and John Straub, a U of T alumni and Waterloo, these two guys are kind of the North American gurus. They run a company called buildingscience.com. Strongly urge all of you here to check out the website. They have amazing technical literature ad nauseum. Okay, they've got a lot of good technology. So basically, what Steve Rick is saying here is it's a balance. It's a balance, and the balance can be upset. If the balance is upset in summertime, we don't really care. It doesn't hurt us too much. But if we upset the balance in wintertime, it matters. And so the whole analogy here is that if we're filling the bucket at the same time that the whole of the bucket is draining or drying, so if it's wetting at the same rate that it's drying, then that's fine. That's fine. The problem is in wintertime, things don't dry very well. So there could be a time when the bucket, the saturation of the brick is reached. So basically there's a critical point of saturation where the brick gets too wet, and if it freezes, then you'll start to find the brick popping off. And here's what happens, and I don't understand this Fahrenheit stuff. So I'm going to have to talk to, they're both Canadians. Why are they putting everything in Fahrenheit? What's with that? Fahrenheit. I don't know what 32 Fahrenheit means, but I think that's freezing.
That's zero.
So it's outside, warm inside. Here's the second scenario where we've insulated the wall outside, inside. So in our old houses, the temperature inside was at 70, and as we went closer to the wall, it got colder. And you can see here the temperature profile drops as we're coming through the brick. And then right here, basically, we've got this layer here of frozen brick. Okay? So that's basically what's happening in our old houses for a good portion of the year in the heart of winter, is that we've got some frozen brick. Now, if we insulate it from the outside, is we're cutting off this wall from all of that brick. Okay? All of that warmth. And so what happens is the temperature profile here comes and it just drops right down here. So to the point where actually almost the entire brick wall is completely frozen. So that's
Inside,
from the inside.
outside, that's insulation from inside.
Sorry, yes. Yes. That was just a test. How do I know if I have double brick? And this is definitely double brick. You can see the two courses of brick. So this is a little triplex in the Rosedale area. So you can look for tie bricks. So tie bricks are when you have the little bricks turned on their side, okay? Every fifth or sixth courses. So those bricks sort of are what to look for. Here's a 1960s block and brick. You see on the next slide what it looks like in the attic, and you can see that sort of beige brick on the outside, brick on the inside. And there's the concrete block, the cinder block on the inside. Here's an example down my street of a lovely renovated double brick house. There's another house near my house, which is also a double brick. And here's a house that's kind of tricky. This is maybe like your house, right? So this is a house that looks, it's standing with a lot of other brick houses, but when we look at it, there are a few little things usually with these houses. Sometimes they have this feature here with a little angled brick. And usually it's only the face that's done in brick. And this was always the clue to me that, oh yeah, this is probably, when I see this feature, it's probably single brick with wood frame on the inside. And usually that's where the floor cavity was. And you can see the stucco here covering what's likely, this is the U of T building downtown. So this is, it's likely stucco on wood frame here. Here is Cabbagetown House. And, again, the face, it looks like a classic red brick house, but it's, when you look at the side here, there is that stucco finish, and I take my measuring tape, and I was literally able to stuff it right in the wall, 6 inches in, and it's completely uninsulated. What a great opportunity. And houses like this, are so easy to retrofit. If anyone has a wood frame house in Toronto, I am immensely jealous, because the opportunity is there for you to just really do a great job. And cellulose is fantastic. Very easy. I mean, personally, I would probably pop off the baseboard, clean out all the schmutz. That's a technical term. and then lay on another piece of, and then have a company do a dense packing where they physically, with the tube goes all the way in. And this is a problem in Canada, is that very few companies know that they need to tube walls all the way. I didn't know that when I first started, okay? And there's a lot of houses that I've insulated that I regret. If I would have known. In Canada, we didn't have the programs like they did in the States. In the States, they had consistent funding throughout time, and they really built up a cadre of competent insulation appliers, okay? So these people retrofit houses, there's standards, there's training. There is none of that in Canada. And it's very sad, because cellulose is a brilliant material. But what I want to say is that if you do have a wood frame house, cellulose is fantastic. It's cheap, it's quick. When it's dense packed, you notice immediately. You can't hear the complaining in the house next door. The traffic, it's amazing. I've had people just say that literally the temperature in the house changed overnight. The more comfortable throughout. Anyways, great opportunity. So, does anyone have any questions at this point?
Is there an issue with the cellulose settling a little bit? I know you mentioned that it's dense packed, right? But
Yeah.
I know there's a lot of people that said that putting any sort of loose fill type of insulation, that between the studs, they are going to settle a little bit and have a little bit of gap on the top.
So, back when I was a kid, there was this thing where you'd take a sponge, and you'd take a sponge, you'd wet it, and then you'd scrunch it up, you'd tie a string on it, and I never did this, and then you let it dry. And then you go to the school, and you take the string off, and you throw it in the toilet, and you flush it, and then the sponge expands again. The point is that the sponge expands, and it pushes out. There is a pressure innate in that sponge, where it's pushing out, and literally you can push on the wall and it'll bounce back, okay? So when you have that density, it will not settle.
Okay.
Full stop. But you need to find somebody who knows how to get it to that density. You need you need the right equipment, and you need somebody who cares about insulation. So the person, I always say about spray foam, don't choose a spray foam company. If you're gonna go with spray foam, choose the sprayer. Ask for the sprayer's name. Get the name of the sprayer. I don't care who the company is. The guy pulling the trigger is key. If that person has a little bit of building science training and has experience with that chemical, the application process, they're worth the weight in gold. Hire the sprayer, don't hire the company.
Can you get better density in sealing with like wet sprayed sealants?
Okay, so wet sprayed, there's very few contractors who do that. And wet sprayed cellulose is usually applied on an open stud wall. There's no drywall. And what you do is you spray it in, and then there's a binder in the cellulose, and it stays stuck. You clean it all up, and then once it kind of firms up, you shave off the surface, and then so it is not a retrofit. So if you're going to keep the ceiling in, or the wall, or the drywall, or the lath and plaster, you can't use wet spray. So you'd have to use like a dry cellulose. Am I answering your question? Or?
Yeah.
Okay. So yeah, the wet spray, we were at a house in Prince Edward County that had wet spray in it. It was a great job. It was a double stud wall, and yeah, a fantastic project. Very airtight, and it did a nice job. You know, in Canada, it's not like Florida where the humidity levels are super high. Generally speaking, that wet, if you're allowing the humidity to dry out, you're okay. Sorry, yes, sir.
We were talking about asbestos and lead when you're renovating a house. Which level of government should we be going to, maybe I should be asking us, to enforce something like this? Because you're right, we've got, in this ward alone, people love living here.
Yeah.
So when they buy these older houses and they're not big enough, they gut them. What are they gutting, and who do we go to protect the community? Do they have to, sort of put a big tarp around it and lock it in while they're doing this? Who do we talk to do this?
Well, in the United States, it's a federal.
I like the sounds of that.
Yeah. So, and because lead paint exists throughout Canada,
It's better to do the whole country, not
It's a
just
controlled
Toronto.
substance.
to me, I think it's a federal responsibility.
So we'll
But
go and talk to our federal representative.
that's right. That's right.
Sounds good to me.
That's right. And I'm sure they will listen to you.
She will.
Oh, great. Maybe in this writing, yeah. Yes.
On Love It or List It in Vancouver, if they find asbestos, they have to go to the city and say, we found asbestos. And then the city says you have to do remediation in a certain way.
It's the Ministry of Labor that regulates asbestos and abatement. So they're the ones that I think they're provincial.
But Health Canada Health Canada was the one who put their nose in the both in asbestos as well as with the UFI, urea formaldehyde. It was Health Canada that sort of waded in there, and man, did they get spanked. I mean, there was such an overreaction with urea formaldehyde, we learned a lot. It's being sprayed in the United States as we speak. So, sorry, any more questions? Or maybe I should keep them till after.
But just to add on to this, because you said keep safe, and it's a problem, it's just, people have recommendations of even a company, because I called around so many companies, and in the end, we just had problems, they didn't do it right, but we, just actually finding a company to do it in a safe way, that's also.
I guess what I was getting at is, for the person working in the house, it's an occupational hazard. For the homeowner who's living in the house while the renovation is going on, it's an occupational hazard, but you're living in it. Your exposure's 24 hours, so to me, that's where, if you're planning on living in a house while you're renovating it, if you're gutting it, that to me is just, I just put it out there because I think it's important to share that there are negative health consequences that can.
So I just wanted to broaden it. When an old building is being torn down, a commercial building or whatever, who's responsible for making sure that the asbestos that's being ripped out of the old building isn't airborne and going through the whole neighborhood? Whose responsibility is that? Like, what regulations govern that?
Yeah, I would say, as this gentleman here said, was the Ministry of Labor?
As far as I understand, they're the one that sets the regulations for how it has to be done. So where do you separate it? So for example, if you had vermiculite insulation in the attic that you had to remove, in the attic that had asbestos, the way you would actually have to compartmentalize the building, and how would you, make sure that they remove that asbestos insulation That, the rules were set by the Ministry of Labor. And that's why it's so expensive to get a proper asbestos abatement done for just removing loose fill insulation in the attic, which, you know, people will do with a shop vac sometimes.
Okay, so is that Ministry of Labor provincially?
Yes.
Provincially?
Right, yeah.
Okay, because, I would take issue, not with you, but with protection of neighbors around the building that's going down. You know, we've lived through the demolition of an older chronic care hospital where none of us were told what was going on. So one morning, you know, the big bins arrived, I went across the street and said, "What's that?" And the guy said, "Oh, we're removing insulation." I thought, well, that would have been nice to let us know, wouldn't it? You know?
For any of you interested in advocacy, I have access to a very great group that please get in touch with me afterwards and I'll put you in touch with them. I think that would be a fantastic starting point. They've got a lot of the talking points and white papers surrounding what's necessary to move this up to the next level. I think it's political will at this point. Building science. I'm going to put everyone to sleep here? No, just joking. You're going to be tested. Okay, so heat moves from more to less. Humidity moves from more to less. So that's the movement, okay? So the vector is from more to less. So now I'm going to ask you, in a house, heat moves in which direction? A lot of people say up, and you're right. It's just like a hot air balloon. The buoyancy of air is up. You're right. All right? Now, let's put that one down. We lose heat in all directions, including through the floor. Okay? So just bear that in mind. So when you insulate and air seal, go all around. 3 modes of heat movement. There's conduction. We've all grabbed the frying pan too early. Convection. So if you have fiberglass in a wall, you'll have the heat on this side, the cold on this side, and the hot and warm air inside the wall. Believe it or not, there's actually a little bit of air plowing up the wall, slowly gets to the top, and then it goes back down, it cools down. So a conveyor belt is bringing the foam through. So what's the R value of fiberglass about? 3. So now if we take spray foam and we look at spray foam, can we get a conveyor belt going in spray foam? That's right. So that's why the R value of spray foam is a lot higher, because there isn't that conveyor belt going. Okay, there's no air movement through spray foam. And the last is radiation. Oh, so this gentleman here, he's got his jacket on and he's sitting right next to this projector that's probably cooking.
I like the warmth.
Yeah. It was a brutal winter, so you're still recovering, I guess. So this is what I wanted to show everyone here, was there are 3 causes of unintentional airflow in the house. And I say unintentional, so this is not ventilation. So this is unwanted ventilation, this is air leakage. And the last one is a little bit of both. It kind of muddles along here. So Paul, we're kind of bringing you back to, so first is the wind effect. When we're pushing on this side of the house, the air does get in, and on this side, on the leeward side, we're getting the suction, pulling it back out. So this is the wind effect. When you get those strong north winds or west winds, they literally push air through a house.
So, is it coming through the brick? Just comes through the brick?
Sure, why not? I mean, there's no, I think if we ask ourselves, on a windy day, would you rather have a layer that is, or let's bring it back to the blue jeans, the kids, we all had the blue jeans, big holes at the knees, and when it gets cold, those blue jeans, that rip open, means that you're going to get a lot more air heat loss right in those immediate areas. So if you can have a continuous skin, then fantastic. And in our houses, there's no continuous skin, and that's part of the problem in our houses. That's why people are doing deep energy retrofits. The definition of a deep energy retrofit is when you've got a house and you install a continuous air barrier from top to bottom. Okay? So we build our little cocoon and we put our insulation as close to that air barrier as we possibly can. And then we install a ventilation system. So wind effect, cover that one. Stack effect is literally that hot air balloon. And I always joke around, if I said, okay, I'm sending you up in a balloon, you're going to go up, and I'm gonna shoot a hole in your balloon with my gun. It sounds violent. But I'm gonna give you the choice. Are you gonna allow me to shoot a hole through the bottom half of the balloon or the top half of the balloon? This is a life or death situation here, guys. Bottom, right. You can have holes in the bottom, it's not a big issue. There already is a hole in the bottom. But on the top, if you rip a hole at the top, you're losing your pressure, right? So it's like a flat tire. You're just gonna lose all that hard air and you're gonna come down slowly. It's not gonna be that bad. So I'll just shoot a small one. So that's stack effect. So for every cubic meter of air you lose through the top, you have that cold cubic meter coming in, and that's unconditioned. So that's cold, dry air coming in and hot moisture leaving. So the taller the house, the more this stack effect is pronounced. Next is combustion and ventilation effect. So if you build a fire, we're sucking air out of the house and out the chimney. If we're using a bath exhaust fan, we're sucking it out. A range hood, we're sucking it out. So those are all ventilation effects. And we starve our house of air, and you can see all the little vector arrows here where the air is coming in to replace it. And it's uniform throughout. Next is moisture sources, and I said here people because it's missing. Showers and baths are big ones. Plants, cooking, if you like to, sort of cook big soups and stuff. So drying clothes indoors is a really big one. Wood isn't so much of a big one in Toronto, but some people are adherents. They love, wood. Foundation leaks a big one if they got a crawl space, a dirt crawl space. It's not a good thing to have. And hot water appliances, throughout. So having an inventory of where those moisture-producing appliances are is good. Knowing where the moisture in your house comes from is very important. Yes.
Just a quick question. What would you recommend for a crawl space to try and insulate it instead of having just earth?
If you've got just earth, really the simplest thing you can do is just put a poly on it. Lap seams and just put a poly on it. It's, it doesn't even have to be a 6 mil. You just want to stop that evaporative transport from happening. Cheap and cheerful, I mean, I've done, when I first joined Green Saver, I was the guy in crawl spaces and attics. And, I've been in a lot of, taking out the rat carcasses, the pipes, the rotted whatever, bed frames, you're pulling all kinds of, just to make a nice even surface, So, but the walls need to be insulated, etc. But I digress. So in our old houses, so a lot of us have knee walls when we're losing air, and I always like to joke that literally you could take a bowling ball, roll it from this side of the attic all the way out to the other side of the attic, because there's no air sealing underneath the knee wall here. And it's something when I was at Green Saver, we used to do a lot of this air sealing down here. Makes a big difference. A lot of people really worry about the ventilation here. If you want to worry about it, then worry about it. Whatever. I think that our value trumps air sealing your attic floor trumps ventilation of the attic. And we're not talking ventilation for breathing. We're talking just drying potential in an attic. Does anyone here have ice dams? No, some ice dams. So ice dams typically are not a function of not having enough, the roof vent taps. It's not because you don't have enough of those. You don't need more of those. You need to actually air seal. You need to patch up all these little holes. You need to stop the heat, the heat from getting up there. Once you've stopped the air leakage from getting up in your attic, then and only then should you add more insulation. You can add all the insulation you want in the world, unless it's spray foam and unless it's really well sealed. Adding loose fill insulation like fiberglass and cellulose, it will do nothing for solving an ice dam. You need to air seal first, air seal first, air seal first. Okay, so picture of a house that I was at, East York. So key concept of air leakage and diffusion. There was a gentleman here earlier. We were talking about moisture condensing inside my wall, and if I get too much R value, then there's a potential that I will have if we go back to that slide where you see across the wall, that condensation from inside air coming to the outside is only a concern if we have a lot of air leakage. Because by diffusion, the amount of moisture that will actually go through a surface is very minimal. But if I make a hole here, we're gonna see, it's like the ripped jeans. If I make a hole, then we've got to wait for a huge transport. So if I ask you, if we have a scenario here where we have a Coke bottle, and we blow into the Coke bottle, how much air can I get into that Coke bottle? I can't get anything, right? Because I'm just compressing the air. So there's no constant flow of air in that wall cavity, in that wall assembly. I can blow as hard as I want. I'm not getting a flow. But if I make a tiny hole on the bottom side of that Coke bottle and I blow into it, now I've got a flow. And now condensation is really going to be an issue. So if you have an airtight building envelope, you are going to have a more durable building envelope. Airtight means durable. And that's what we get here. One hole will give you 30 liters of water over a season, but through diffusion, through a skin, doesn't matter. As long as it's continuous, painted drywall, 1/3 of a liter. That's not enough to destroy a wall. So then Zen Master says, significant moisture movement can only be controlled by stopping airflow. Flowing air needs only two things: a hole, a pressure difference. Okay? Next, we go on to thermal bridging. And obviously, thermal bridging, we like insulation, we like R value, but when we put up a frame, you know, to hang our drywall in our houses, because our brick is structural, you know, ideally, we wouldn't put them up at 16 inches on center unless we had to. You could put them on 24 inches on center. So in this case, if you reduce the amount of lumber that is enough. So this, if we take all this lumber, we squish it all down here, about 25% of the wall is lumber. And the R value is not good on lumber, R1 per inch, you know, so that's an R3.5 on a 2x4. And, you know, 75% that it's possible to reduce that a lot by just putting in less wood. And, you know, thermally, if I took an infrared camera, it would look sort of like that. It would look like, yeah. Anyways, I should take some real thermal images instead of using this purloined image. So before you start, what's the most ignored aspect of every retrofit? Nay, every newly built house. Very few houses are tested for air sealing. Okay? So, and I ask you, if you've got these two, this is Ed Marion. I don't know if any of you know Ed Marion, passive builder in Oakville. This is his analogy, so I can defer to Ed. The coffee cup and the thermos. We all love thermoses. What a great invention. But I ask you, if I take the lid off that thermos, will it be as efficient? It's not air sealed. Part of the success is the air sealing. A big part of the success is the same thing with a house. Now, you're right, we need to breathe because we're going to go in that thermos. You're right. So let's put a mechanical system that breathes for us at a prescribed rate. Do we ignore air leakage in our next upgrade? No. Test before the drywall goes on so you can actually correct what's wrong. It's too late once the drywall is up. People are always like, oh yeah, we'll test once the drywall's up, it's painted and all that. It's like, it's too late. Who cares about what it's going to be after the drywall's up? With an airtight house, we need ventilation. So this is getting back to Paul's point. In with the good, out with the bad. When it comes to ventilation, balanced ventilation is better than exhaust only. And so here's an example of a balanced system, a balanced machine. It's called a heat recovery ventilator. Sometimes they're called ERVs if they have a different kind of heat exchanger that reroutes the moisture. And a lot of our houses still don't have bath fans. So this is called point or exhaust only ventilation, and it works. So this is in a new house. You can see here this bath fan is exhausting out through the roof here. So this is both in and out, and ideally it's balanced. So for everyone brings in, it exports one, and it exchanges the heat from one to the other as they pass through this core here. This one here just sucks out, and so it's very indiscriminate, and so you've got a lot of cold air that comes back in. Key concept. Houses don't need fresh air, the occupants do. Ventilation is not something you let the building shell take care of. Through leakage, ventilation needs to be dosed precisely. And I always tell architects, like, think of it, if you're trying to if you want optimal health, if health is important to you, tell your clients that it's a dose of fresh air. Like your vitamin C, or it's like your pill, you gotta take it every day. It's called oxygen. How many glasses of water does a person need a day?
8.
Universally, we all sort of, I think we were all taught as kids, like, oh, that's 8. So this is 8, we get 7, 8, and it comes up, it's pretty funny. And then I asked this question, and everyone's like, I don't know. And it's funny because I can tell you right now that I could go on a whole day without drinking a glass of water. But I can't go more than a couple minutes without a breath of fresh air. So it's interesting how we were never taught anything about how much air we need, but we know how many glasses of water we need. But we kind of know what we need. So, and I like to say that a cubic foot per minute per occupant, so 10 cubic feet per minute per occupant. And so if I do the math here, it's 1,400 cubic feet per day. And sort of think of a cubic foot as a basketball. So that's 1,400 basketballs coming into your house throughout the day. That's for one person. Now, Ms. Garno, you've got to come back. Come on. Okay, so basically the tests for, so how they came up with this 10 CFM figure is basically, oxygen, high amounts of oxygen, minimal carbon dioxide, and no BO. I was kind of trying to be funny here. But literally it comes down to, at what point do occupants sort of start to smell a little clammy? And basically, they'll find that 10 CFM is about the right rate of ventilation per occupant, where you don't start to smell your kids or your kids smell you or whatever. Built tight, ventilate right, an airtight home means greater efficiency in summer and winter, more quiet, better quality, more durable walls and attics, more comfortable, less drafty, less liability. Your HRV will earn its keep. If you're investing in an HRV, why don't you make it earn its keep by having an airtight house? Site assessment. Durability depends on water management. Assess the whole envelope and repair. So the foundation, type conditions, brick type, texture, mortar joints, soil grading issues. These are all things that you need to look at when you were looking at our houses. So great architect in Chicago, Bill Rose says pick 2 of 3 for your house. Use the 3-legged stool turned to 2 legs. Great efficiency, museum quality, durability, or preserve the exterior. And so this is what we all balance in our day-to-day lives. Pick 3. It's not a way to go. Priority insulating, stop gross water ingress. And this is something that I learned from an architect in New York called Chris Benedict. She has been doing amazing work with brownstones in New York, where she will gut them, make sure that everything on the outside is really bulletproof in terms of water coming in, and then she'll dense pack them with cellulose. There's no vapor barrier anywhere, so the wall can breathe to the inside, it can breathe to the outside, and she's, it's been really, really stunning what she does with these old buildings. Protect the mud sill and foundation floor joists. Waterproof foundation from the outside to prevent wet feet. So I say this because, basically I think nowadays the idea is that, you've got your boots on and your house is in the water. The feet are in the water. Now, ideally, you would waterproof from the outside, you have drainage on the outside, so that my feet are dry. Because what happens is if my feet are wet, the water comes up my legs, it comes up the foundation walls, and eventually it comes out to the sides, either on the inside or the outside, and it dries and it weakens, degrades the brick. We'll show pictures of that in a little bit. So all the strategies that do on the inside, it's more of a band-aid, and it works, but it's certainly not my favorite in terms of having the wet feet. It's a great exterior. So where does the evil water come from? It comes from rain hitting the walls, gross water ingress, sun driving the moisture deep in the envelope. So in other words, if it rains on this wall and the sun is beating down on it, that moisture is just going to be pushed through what they call the vapor drive. That moisture is going to be pushed through. I'm beating up your sign here all the time. Through the wall assembly and gets very deep in the wall, especially on roofs. Wet foundation, and uncontrolled air leakage from inside to outside. Here's the different types of foundations. And generally speaking, in these neighborhoods, we're looking at rubble. Okay, and some brick, and some of us are lucky, we've got poured concrete, some of us have got some concrete. It is a mixed bag. The beer can was only for perspective. I was not drinking on the job. So this is my cousin's place on Mariah Street. The contractor was repointing the stones and just pulled out all the loose stuff. Literally, you can stick your hand in there. My own place, I dug out my own foundation, and I was literally pulling out hands full of sand, and I was like, oh, jeez. You know, what is holding these houses up? And, you know, with the collapse on Mariah Street, it wasn't my cousin's house, and this collapse, and just more recently, you know, when you're underpinning a house, number one, I've seen some very nice work, and I've seen some just work that drags on for a long time, and I think that underpinning is something that needs to be done pretty quickly, or, you know, generally speaking, you want to try and shorten the time that everything's open. And there are some techniques. I saw a company, they do what they call an over-pour method, a company called Tall Basements here in Toronto. I've never seen anything like this, and it looks absolutely beautiful. The underpinning is actually flush with the above grade wall. It was a beautiful job. Not that I'm endorsing them. All I'm saying is that the one house that I checked out was certainly a lot different than the underpin jobs that I've seen, where they've built out, and the forming is terrible on it. So this is the wet boots. This is the wet feet here. Capillary reaction. The stone, the mortar that holds the stone and the bricks is very, as well as the brick, the clay brick. They draw moisture up. And they dry it out. So if we paint this, it doesn't care. It'll either bubble the paint off or it'll go higher. Okay. So here you can see the spalling of the brick here. Okay, it's pretty genteel right there, but you can see, it's all patchwork here. There's a lot of, basically slanted. You should be able to see a nice slant, and it should be sealed. Okay, here's a parapet wall that needs, better parapet cap. Perhaps, they take off this cap and put a through flashing. Maybe they make just an aluminum cap. But you can see there's definitely a lot of rainwater getting into it. And some poor guy was using spray foam to repoint the bricks. This one here is across the street on that street, this chimney. All these pictures were taken in the neighborhood here. So you can see here they put a new chimney on to the old stuff. But literally, and I'm sorry I didn't show it, but you can see the top of the chimney, which is a key point in this whole presentation. And I'm not even showing it. This reminds me of my mom. She took a picture of my brother, and we found an owl on the side of the road. And she tells my brother Tom, she says, "Okay, Tom, stand there. I'm going to take your picture." So we get the pictures back, and of course, Tom and I are standing arm in arm, like this, and Tom's got his hand outside of the picture. You can't even see the owl. It's like typical mom, look at my sons, forget the bird. So, anyways, that's the top of the chimney. There's no cap on there. So there's a lot of moisture coming into this chimney here, and degrading the brick. So a lot of the treatments, you can see right here, there's a divide. This is my neighbor's house. I always feel like a freak taking pictures of people's houses. They're all like, "What are you taking a picture of my house for?" So you can see this is the original brick, and right here they use something pretty caustic to sandblast, or they've taken off basically the strongest part of the brick, which was the cooked face of it. So that's a lot more porous on this side than that side. So certainly be careful if you're doing some work on your brick. So here's an example of just keeping little bits of trough clean, roofs clean. So the roll lock here, you can see that it was repointed, but it's just really deep. Roll lock sills are just never a great. It's never a great sill. This is my house. You can see here, it's got a nice little line right in here. Does anyone know what that line is for? Drip line. This is drip line. So the water curls around, and it gets to that, and says, "Well, I'm not going to go up." So it just drips down here. So it's something brilliant and simple little detail. Just a little drip lip keeps the water from getting in the wall. Here's that fluorescence picture taken yesterday in my neighbor's house. Spalling. It's in Rosedale, so this is where the face of the brick literally pops off with frost. That was this past winter. And people always say, oh, I can't waterproof between the two houses, they're too close. Well, it can be done. You know, this is maybe 3 feet between the two houses. Does that make sense to everyone here?
That's less than 3.
So there we go.
Any idea how much it will cost to do something like that to the other side?
Well, this is tough because unlike, you know, a wall where you're just pulling the dirt, you've got to shovel it all up. I mean, the basic is $100 a linear foot, you know. But this, you know, they managed to do both at the same time. Again, you know, there's ways to do it without doing that. You can make a thermal bridge and connect them both below grade by insulating the slab. There's lots of creative stuff that Enercan had developed back in the 70s, back when we had research. Structural brick, so these holes here, did anyone tell me what these holes are for?
Joist cavities.
That's right.
Joist pockets.
So you can see I moved the picture around here and I forgot to rejig the arrow. This is called mud sill, okay? So that mud sill, so people like Joe Seabrook suggest that we should not orphan it and not spray foam over top of it, because now you've got wood right in contact with a really, really wet foundation part, and it's going to eventually rot, okay? So what he would suggest is you pick it up and you put in sheet good that is a capillary break underneath it, or you just replace it. And it's not something that is insanely hard to do. It could be a day's worth of labor where you resupport this wall and just replace it.
So just to go back to that one, so to make that airtight?
It's part of the airtightness, but it's also because once we bury a piece of wood on the cold side against the brick, it has no way of drying. It's orphaned wood, and that wood will dry, and eventually your floor is going to list. But it could be for the next homeowner, you know, whatever. You know. Tongue in cheek, sorry. No, this is Christy Pitts. So I was cycling by and I was like, holy cow! I couldn't believe it. It just took the face right off this house. Here's a grate. You can see the double brick here. They just cut it with a saw. Interesting here how the brick, they just brought the brick in a little bit just to hold this up. You know, this joist up, and you can see these joists are right in the wall here. So that's the second floor. There's a cleat here that ties in the course to give it a little bit of side-to-side strength. But on the main floor, in this one it doesn't show it. This one here shows it going right in the double brick. And in a lot of houses, it's not actually like that. It's actually more like this, okay? For the main floor, it actually doesn't go into the double brick. It rests directly on the foundation wall. And so that one's a little bit different. But the top floor walls, it's not as prone, but I would suggest that, you know, liquid applied air barriers could be put on there to stop. There's still the potential of rotting the ends of those joists, and that's an issue with a lot of old houses, you know, because we're going to spray foam around here, and we're going to see that there's still air leakage. Air leakage is the biggest one. If you can stop the air leakage, you're going to stop a lot of the moisture from attacking that wood. Windows and doors. Dr. Joe Stewart says, there are two types of windows: windows that leak and windows that will leak. And basically, you know, and when I say leak water, and it eventually goes into the sill. This is what happens with windows as they age. And what I meant here was for pan flashing around windows. You know, all this detail. I didn't include a picture. I should have included a picture in that. But I'll jump onto this. Here's houses just going brand new houses, a series of houses going up in Ossington. Just the height of craziness. I can't believe the detailing here. This is a brand new house. The window, concrete foundation, and the concrete, or the window is in the concrete, in the plane of the concrete, but the insulation is here. And it's like, how are they going to match that insulation layer? So matching your insulation layer, you know, same thing with the door here. You can see this concrete here. That door should have been brought in. The problem is that if you don't have the door on the outside, the door hits the wall, because if your wall is too thick, it's an issue, I understand, but it's a design issue. You can design around it. That's why architects or people with the experience of deep wall assembly is very important. So here's a house, I think up in Laws. The addition to the house was insulated. You can see, this is, as one architect I know, Roger Algie, who calls that little room on the back of the house, he calls it the wart. It was built, between the wars, not a lot of money, and they just wanted a little room to put their shoes in, hang their coats, put their sack of potatoes, whatever. And now we take it and we're like, oh, we're gonna warm this place up. There's always issues of air leakage, and you can see just the tremendous amount of air leakage, the cold spots here in the house. This is another house in this area here, put on a new addition. They use steel here, and generally if you're going to use steel, steel goes either in front of the insulation or behind the insulation. You don't put steel in the insulation plane because it's like the cast iron frying pan, it bridges everything. And you can see here, I don't know if this is thermal bridging or if this is just air leakage between the old and the new, but managing the old and the new. The old and the new is another house in my neighborhood. The old and the new. The old and the new, there's always leakage that happens there. You can see here, they've got the tie back, and it's been hanging out here for a number of months, and you can see that it's like, they get to a point, and they're like, okay, now what do I tie it to? Well, I don't have anything to air, what's my air seal layer? So it's an issue. If you're not attacking it, the whole house all in one go, it's a really tough thing to do. So, ditch the Rumford. And I'm going to start a campaign, get rid of these bad boys. They're great for roasting pigs, but we don't roast pigs anymore. So, you can see here that, with a little bit of depressurization, just the plume of cold air coming into this house. You can see right here, this was a hot spot. Why is that a hot spot? There's a little register right there, a little heating register. New floor joists. So a lot of the houses, you start tearing things apart, and you notice, oh my gosh, my floor joists are all undersized. So on come the sister joists, in come the LVLs, and this is what it looks like after it's spray foam. This is again a house, I think, some Laws.
So just a question again, and the seal over there, I find it interesting. No, the next one. And they spray foamed it, and so is the chances of the joist getting rotten in there because they spray foamed it? If I'm looking at it like that?
I think there is the chance. I would say that on the second floor.
Oh, on the second floor? I thought that was basement.
Yeah, no. I think on the second floor there would be less of a chance, but on the main floor, which is closer to the rubble foundation, I think the moisture content's a lot higher there. It might, it's a regret. I wish that I would have, thought about. Steberg hadn't done his study on, lifting and putting a piece in there before I did mine. Back when there's a lot of regrets I have on my house. But that's the experience for other people. So, back at the time, there was this thought that, oh no, you need to have an airspace between the wall and the, and if anything, that is a convective loop that just moves moisture around. And anyways, so here's it's interesting here, really, I think that what could happen in a lot of these houses, you could just re-support the joists and have a new inner skin that just re-supports itself and brings a little, because look, we've got a double top plate here, and the floor joists are right there, Yes, they're plugged in the brick, but, so now if we do the infrared and blower door, then we're noticing that all of a sudden here, we're pulling in a lot of air. So this is what the spray foamer missed, and that's why I always argue, test your spray foamer. Hire the foamer for the foamer, and test the work. And then when they have to come back and correct all these little bits, they get better. So, and here is on a blog that we did for Green Building Advisor. This is Renovation, a deep energy retrofit of a house in East York, and the spray foam was bubbling. I'm not sure why, but it was all bubbling, and there was air leakage happening, and that's.
It wasn't a continuous
That's
spray.
my arm. That's totally my arm.
It wasn't a continuous spray. It came back for a second.
Substrate. It could have been a really cold day or really moist. I don't know why, but really that's a question for the spray foamer. They need to answer that. Or the rep, you know, where you call up BASF and you say, look, what the hell is this? You know, but you gotta call them on this. Argillus and Clinker, great contractor here in Toronto, just they were not, there's a few builders in the Toronto area, they're just happy to have the work tested by a third party, which is crazy because they're basically saying, find faults in my wall assembly. Yes.
So you hire somebody to come and spray your house, and you're showing the example where they've missed or bubbled or whatever. Who has the infrared light to be able to detect that?
Sorry, is that a conflict of interest? Yeah, no, these are all pictures that I took. I mean, most of them. There are some that are purloined. If they're purloined, I usually give credit. So here's a great one. This is in my neighbor's house, and I know the spray foamer, and it's just kind of sad because, you come here and you're like, you think you're doing a good job, and this is with my students at Humber. The pot lights are just leaking like a sieve. Okay? So, just to let you know that pot lights, I don't care what they say, pot lights on the top floor will always leak. I have yet to see an electrician or a contractor do a good job. It's almost impossible to get a perfect seal. And I say on the top floor of your house, just don't put pot lights in. Just don't do it. Or build a false ceiling, air seal, build a false ceiling, drop it, and then put your pot lights in there if you want it, if you need pot lights. So, this is what pot lights look like on the back side. So the electrician comes in, clears everything. This was like this for years, anyways. It's amazing, the hubris. I come from it, three of my brothers are electricians, and I keep on telling them, I hope you guys don't do work like this. So underpinning versus bench. So here's an underpin job. Again, this is on Mariah Street, where they've done the tuck pointing wall of stone here. Looks really nice. There you can see a small bench, of what a bench footing might be. So usually the bench is a little bit larger. So insulation options should be noted that some experts believe the safe R values of brick be limited to R12 unless you have your brick tested or inspected by them, which can cost quite a bit of money. The Reap House in Waterloo, there are examples of many houses that have more than R12, substantially more than R12, that are still standing and are not showing signs of wear and tear. And I'll go through an example. Here's roof. There's my house. There's Dr. Richmond's house in the East End. Terrell Wong's place. There's a ton of houses that are being spray foamed right now with more than R12. Okay, so I think that the message is take care of the water, manage the water, because there is the potential to ruin your brick for sure. So there's many houses.
Sorry, you mean if you're insulating from the outside?
No, well, like I said right at the beginning, outside, put in R100. Who cares? Outside, you can do whatever you want. It's carte blanche, right? Because all of that structure is nice and warm, and I presume that there's drying potential to the inside if it gets wet.
Mm-hmm.
So yeah, if you're doing it from the outside, there's very few risks, except where your roof, the details where the roof meets, parapets that are sticking up. It does get dicey in terms of air leakage, but it depends on the house. It depends on how clean those different planes meet in terms of air leakage. In short, there are many houses more than R12 that are not worse for wear. So here's a Reap House in Waterloo, and this is on the inside. They've got like this whole idea, like here's spray foam. This is what the raw brick. You can see a little squirrel here. They're basically using it as a test house. And this one little patch of brick, what it shows like on the outside, as you can see here, there's a little hot spot on the outside. So it's kind of interesting that the wall insulation is very good throughout, and there's no chance, it's not stalling, even though their downspout and rainwater collection system is just pissing rain all over the little corner of the house. You can see it's all saturated with water here. Okay, so mind the water, but even still, and that's the same kind of clay brick that we have in Toronto. It looks good, and it's been like that for the last 10 years. So the deep energy retrofits, the DERs versus the shallow energy retrofits. Shallow energy retrofits are basically where you just, you're doing, weatherization, you're caulking baseboards, you're dense packing, et cetera. They're all, so I've got a book back there on weatherization. By the way, I've got my own home library on display back there. If any of you guys want to check out some interesting books. The R value needs to be, so if you're, whatever you decide to do, make sure that you've got at least a minimum R5 layer that's continuous. And with that layer, make sure that you have an air barrier that you can attach it to the windows. Any penetration, if it's a pipe that goes through, you attach it to it. Usually with tape. If it's a window that goes through it, you attach it to the tape to the frame. And everything is sealed, because when that moisture goes through it, any breaches, it condenses on the cold side. We don't want that. The house, so continuous air barrier, the house needs to be air tightness tested. And I say that obviously out of greed, because that's what I do for a living, but also because I want your houses to be durable. And building inspectors, nobody cares about testing houses, but we care about testing houses. We like performance. Whole house ventilation needs to be incorporated. And ventilation, when I say it's not attic ventilation, this is breathing ventilation. And the problem with applying for a permit is that if you're building a new house out in the suburbs and you're not using any existing part of the house as a structural element, then you have to do a ventilation design for the house. But if you're just adding an addition or adding a second floor, you don't have to do it. And I'm not sure why that is, but we found a couple of houses in Toronto, just in the last couple of weeks, we've had a couple of people call us up saying, well, why is this happening? Why won't my rubber fireplace work? And we say, well, send us the mechanical design, and they send us the mechanical design room by room, but they don't send us the ventilation design. We're like, well, where's the ventilation design? We're like, there's not required. It was like this big eureka moment. It's like a big hole in health and safety that you can drive a truck through. And of course, when using steel, place it on the inside or the outside of the insulation. Steel's okay. I mean, I like wood, but so this is the old hockey stick analogy. So this is the R value of an assembly, and this is the heat loss. Okay. So the heat flow when we have R0 is infinite. Okay. Now the attenuation is very quick. So we add like R5, and pretty much, like you can make a really good argument. Let's just stop at R5. But I mean, if we're gutting a house, why not go a little bit further? So the building code is roughly at R20 right now, and a lot of passive house enthusiasts are building at R40. You can see that, the effective, reduction is, it's not a lot, okay? But, certainly, I do think that heading higher is better than just putting in R5. So there's some companies in Toronto that are doing injection where they just put a matrix of holes on the wall and they'll just inject spray foam in there. And that could work, but I haven't actually done any physical testing on it. And the problem I have with it is that I've got enough houses to know that when bricklayer are putting the bricks down, on the outside, they rake the joint when they're done. And it's nice and clean. On the inside, it's like, it's just, so you've got all this schmutz that's just coming in on the inside. They might take the trowel and sort of jam it on, but then same goes with the lath and plaster. They put all their wood laths, and then they jam in their cement coat with sand, the rough mix first, and they just jam it in there. And so you've got a lot of stuff that fills that cavity. So we've got little hooky things throughout that prevent the flow of a liquid foam to come in. And my wager is that cavity is at best 1.5 inches. If you've got all these things in there, you're going to have so many little bubbles in the foam that I don't think that the game is worth the candle on the injection. But, I haven't tested it, so I don't know. Final words on the gut. If gutting a hose, take your time to do this. Most people use spray foam directly on the brick. Fur out the walls with wood. And don't be shy, your work needs to stand another century, and no one will miss 3 inches. I really feel that. I mean, a lot of people are like, they can almost get hysterical, on the, sorry, Mike.
No, it's okay, no, never heard that before.
Well, it's something that I'm obsessed about as well. And so, I figure because now that I've gotten over it, I can tell people that get over it, it's only 3 inches. But, I'd like to see someone try liquid applied air barrier, as in New York Passive House Retros. And how do you spec performance, put it in the contract, test pre-drywall, get professional help on the design stage to help flesh out the details, and there will be many. Anyways, sorry, this is another, I just say, you test either one of these, you don't let them test their own work, do you? It's Lance Armstrong, obviously. I'm sure we thought that was funny. So where do you get more information? Building Science Corp, Dr. Stebrick, very great place to, Martin Holiday, Green Building Advisor, New York Builders Pioneering Brick, both women, fantastic. Chris Benedict, Julie Torres Moskovitz, both fantastic people. Torontonians to watch. Solaris Architecture, we work with Solaris quite a bit. Stone's Throw Architecture, Lynch Camiso, right in this area here. The Architects Builder Collaborative. These guys are a fantastic firm. They've done enough building, and they're architects as well, so they understand retrofits really well. I like the Architects Builder Collaborative. Very, very good guys. And builders not afraid to test their own work. Ed Marion, Hardcore Renos, Agris, Clinkard, there are many more. Anyways, I can get you names, whatever you need. Thanks for listening. Any questions?